Hello, welcome to A-Level Physics and Mathematics. In this session, we are going to talk about an essential example of torque. Last time we have discussed about the torque. Torque means, like I said last time, a rotational effect of force, or we call it a turning effect of force, meaning that there is something, let's say a wheel is rotating in a axis of rotation that is called the rotation or the turning of the wheel is called a torque. So meaning that there is a kind of an axis of rotation. If an object is rotating or turning within the axis of rotation, that motion is called a torque. We call it in physics a torque. So we are going to discuss about a very essential example in torque. Before that, could you please like, subscribe, and then share this video? So let's proceed with example. So example it says that this is a door with an axis of axis of rotation, or we call it a hinge. Okay, you can see a hinge or a pivot point. Like I said before, it's basically an axis of rotation. Okay, so we have a hinge over here, and then like I said, the question, it says that consider a door is shown below, which is seen from the aerial view, and then this circle is indicates that the hinge or the pivot point of the door. So find the total or the summation of torque as well as a direction of torque, or each torque. Basically, you need to find out the direction of each torque. So let's proceed with that. So let's find a torque for this guy, or let's say this is F1. Okay, we call it. Let's say this is on F1, or even if you can, it doesn't matter. Basically, you can say F1, and then let's say this guy is F2, and then this guy is F3, as well as this guy is F4. Okay, and then you can say that this is basically. I just wanted to let you know that as you can see the force over here, if you apply a force in the axis of rotation, meaning that there is no position, or there is no displacement or a distance from the axis of rotation. So like I said last time, we can find out the torque of an object is equal to which is equal to with force multiplied by a distance or displacement time with a sine of theta, right? This is a very important equation that will help you to calculate a torque of an object. Okay, now like I said, this guy is 0. Okay, because we did apply a force on axis of rotation, right? Meaning that the the distance from the axis of rotation is 0. So 0 multiplied with this term, you will get a 0, which is equal to basically 0. You can say this uh, uh, 0. Okay, there's no direction because the torque of a object is the torque basically in the axis of rotation is 0. So that is why there's no direction. So that's it for this guy. Okay, basically I did ask you in last session. I don't think so anyone did reply that in the comment section. So yeah, that's it for this one. This force. Now for this or F2, what we are going to do is we need to apply. We need to, like I say, we need to use this formula to find out a torque, right? So what we can do is, like I said, we can use this one, uh, examine formula to calculate to find out the torque. So F or tau 2, which is basically tau, or it's a torque is equal to F2 multiplied by R2 multiplied with the sine of theta. Okay, so basically the distance from the axis of rotation to this point is 0.2, right? So which is R2. Okay, now this is also it's F2, so you can replace or you can plug each given term into the formula. So which will give us, so which is equal to 15 Newton multiplied by a 0.2 meter time with, as you can see, this force we applied a force like it looks, it's basically it's a perpendicular, right? This is a perpendicular to the direct, I mean to the or the to the door, basically for the to the position or a displacement, right? So which is equal to this is a Newton multiply with this, so which is equal to sine of 90 degree, right? Because like I said, this is a right angle, right? So which is equal to, like I said, it is sine 90 degree. So sine theta means is the sine, I mean sine theta, or it's a sine theta, or like there is a sine theta over here. So the sine theta is 90 degree because it's perpendicular to the position or to the displacement, right? So which is equal to basically this guy is 1, right? As you know from the trigonometric relationship, the sine 90 is what? It's a 1. Okay. Now you can multiply this terms, so you will get 0.5. I mean 0.2 meter time with 50, which is equal to 10 Newton meter. Okay, that is F. I mean the torque 2, right? Now, the B or the next question is what's the direction of this torque? As you can see, basically you can determine the force, I mean the direction of this torque using in two different ways. First one is you can see that the force is indicated that the force direction is like basically it's indicated to the into the page, right? Meaning that's a clockwise direction, which is negative, right? To the negative direction, or you can use, or at the end of the day, or at the end of the if I apply the force at the end of the thing, so the door is getting to apply, I mean the door is getting to open up, so which is equal to basically negative, or which is basically into the page, meaning that its direction is, or its direction is clockwise or into the page, which is which indicates basically into the page means basically it's a clockwise, and then that the direction is a negative or up, right? So that is it for this guy. And then for this guy, what we are going to do is a torque, right, which is equal to F3 multiplied by R3 multiplied by sine of 90, right? I mean sine of theta basically, right? So before that, like I said, this is a kind of right angle, right? So meaning that the angle between the position and the force is perpendicular, meaning that the sine theta is 0, I mean sine theta is 90 degree. Okay, so and then one last thing, you need to understand the distance between from this point, basically this is from this point to this point is 0.6, and then the distance from the axis of rotation to this point will have an 8 or 0 point or 0.8, right? So now we have force which is equal to 70 Newton, right? 70 Newton multiplied by 0.8, isn't it, right? 0.8 or 0.8 meter multiplied by sine 90 degree, okay? Sine 90 degree, which is equal to, you will get, like I said, this term is 1, right? So meaning that one time any number, you will get a number itself, right? So now you can multiply 0.8 meter with 70 Newton, which is equal to 56 Newton meter. Okay, that is a torque for F3, or yeah, basically for F3. And then the direction is, as you can see, is a kind of out of the page, right? Out of the page means it's a counterclockwise, which is equal, which is basically it's a positive, right? Which is, I'm not so sure if you are familiar or not. Yeah, it's out of the page, or a counterclockwise means it's a positive direction. So which is equal to, like I said, it's a positive. And then for the next guy, what we can do is, yep, that is it for this guy. Let me know if you have any question regarding with, and I mean regarding any of them, I'm happy to reply for you guys. So like I said, could you please like, subscribe, and then share this video? That will help me a lot. So now let's proceed with the last guy. So which is f4, right? Like, let's say, I mean at f torque 4, which is equal to what? It's supposed to be 4, right? So which is equal to f4, right? f4 multiplied by r4 multiplied by sine theta. Okay. Now you can just plug the given terms in the formula. Okay, that's what you need to do, basically, right? So which is equal to f4 is 80 Newton. Okay, 80 Newton multiplied by r, right? Like I say, the distance from this point to this point is, right, it is 0.6, right, or we can say 0.6 meter. 0.6 meter, right? And then a distance from this point to this point is 0.2. Now we need to find out the distance from the axis of rotation to this point. Okay, that's what you need to understand. Okay, so if you add all of them, basically you need to, what I'm trying to say is you need to add all of them, right, all together. So meaning that if you add all of them, you will get a total distance or total r 1 meter, right? So meaning that you can replace, or you can plug 1 meter over here multiplied with 1 meter, and then sine of theta is over here, which is equal to sine 30 degree, right? Sine 30 degree. Now that is what we need to do. Now this guy is basically 1 upon 2. I believe you are familiar with this or not. If you are not, yeah, like I said, it is 0.5 or 1 upon 2. Okay, now you can just plug this. Then when we multiply 1 with 1 upon 2, you will get 1 upon 2 itself, right? So meaning that 8 or 0.8, let me change my marker. So 80 Newton multiplied with a 1 upon 2 meter, which is equal to, basically you will simplify this term, yeah, then you will get 40 Newton meter. That is F4. Okay. Now we did find all torque, or we did find torque in each position, right? But the thing is, we need to find out the direction for this guy. You don't need to forget that. So the direction of this torque is, like you can see from the force direction, you can determine, basically that will help you to find out the direction of the force. Okay. Now what you can see is the direction of force. It looks like a clockwise direction, right? Meaning that it's into the page. That means it is a negative direction. So right, that is indicates a negative into the page. Basically it's a negative, right? So which is equal to, like I said, the direction indicates that clockwise or into the page, which is a negative sign, or up. Yeah, that is basically an up. Now what we are going to do is we need to find out the total torque, right? That is what we need to find out. Now to find out the total torque, what you need to do is total torque, the summation of torque, right, which is equal to torque 1 plus torque 2 plus torque what 3, and then so on, right? That is what you need to do, basically. Okay, so that's it. And then now what we can do is we can just add all of them. You can find out which is 0 plus what negative, right, which is negative 10 Newton meter plus with 56, right? 50 it's supposed to be 56 Newton meter plus, what is that, plus negative 40, right? Negative 40 Newton meter. Okay, negative 40 Newton meter. So you can simplify this, guys, because it's addition, right? It's not very complicated. This is 56, okay? Now, which is equal to, I think you will get 6, right? Meaning that which is negative, this is 50, negative 50, or I mean, basically it's a negative 15. So 56 minus 50, which is equal to 6 Newton meter, okay? That is a total torque of a given example or exercise, or basically it's a door. Yep, that is all for today. Let me know if you have any question regarding with this example, or let me know if you have any concern on this question. I'm happy to reply to you guys. Yeah, that is all for today. Like I said, could you please, it's not a paid, it's free. Could you please, it's not even complicated. So could you please help me with your best basically you can, what I'm trying to say is you can just subscribe, like, and then share this video. You can find me in almost all social media like LinkedIn, YouTube, TikTok, or Instagram, whatever. I mean Instagram, TikTok, as well as in Telegram as well. So if you have any question, you can find, you can feel free to let me know in those social media, or you can find me using my email as well. Maybe you can find my email in TikTok. You can feel free to contact me through email, or like I said, you can find me in link. You can also find in LinkedIn as well. So yeah, let me know if you have any question. I'm happy to reply to you guys. Have a good day. Enjoy your day. Thanks so much. Goodbye.